Hello and welcome to Math with Mrs. Becker. Today in college algebra, we are going to solve some exponential and logarithmic equations. Now here are just some helpful tips as we go ahead and tackle this task. Exponential functions or exponential equations. If you can make common bases, that's always the first thing that you want to do. Because let's say I have like 2 to the power of x equals 2 to the power of 2. If you have one exponential base on this side and one exponential base on this side, if they match, there's that property that says, hey, you can just totally cross that off and you would know right now that x is equal to 2. So if you are starting off with an exponential equation, step 1, see if there's some way that you can obtain common bases. If you can't, there's a lot of times where that's not possible. If you cannot, what you do is you take the log of each side and go from there. If you are starting off with a logarithmic equation, before you can cancel the log, you need to condense it. Okay, so think of 3.3 when we talked about how you can condense exponential functions. You have to condense it down to just one single log. Then make sure that you do not have an exponent. Remember, you cannot have an exponent on a logarithm. So what you would have to do is go ahead and bring that out front and divide it to the other side, okay? You cannot cancel a log if there's a number out front. You need to get rid of it, and the way you do that is go ahead and divide. So here are some examples. Now this is an exponential equation. I can make a common base because 32 is equal to 2 to the power of 5. So what I can do here is I can replace 32 with 2 to the power of 5 because it has the same value. 2 to the power of 5 is equal to 32. Now I can totally cancel those bases and I know that x equals 5. Done. Okay, the next one. This is a logarithmic equation. Okay, it's a natural log, but it's still a logarithmic equation. So step 1, I need to condense these. This is a natural log, this is a natural log. So I can turn it into one natural log. Subtraction goes with division. So I have x divided by 3 equals 0. Okay, now I need to cancel a natural log. In order to cancel a natural log, you need an exponential base of e. If I have an exponential base of e here, what you do to one side, you always do to the other. E, whenever it's next to ln, cancels. So this side is now x over 3, e to the power of 0, because remember, this is always a base. E to the power of 0 is 1. If I want to solve for x, I need to multiply both sides by 3, because right now this is x divided by 3. So if I multiply by that denominator, the 3 would cancel. 1 times 3 is 3, and you are done. Okay, the next one. This is an exponential equation, and I know that because I don't have any logs within the problem. Again, you want to try to see if you can make a common base, and you guys, I totally can, because 1 over 3 is the same as 3 to the negative first power, okay, because a negative exponent would make it go on the bottom of a fraction, and the 1 would keep it a 3. So 1/3 is really 3 to the negative power of 1. I still have the x there. Now 9 can also be rewritten as a base of 3. 9 is 3 squared. Now here, notice I have an exponent inside and outside of the parentheses. Properties of exponents told us that if you have exponents inside and outside, you always want to multiply them. So this is 3 to the negative 1 times x is negative x equals 3 squared. Now that I have both sides simplified, this is a base of 3, this is a base of 3. I can cancel and I can cancel. Here is my new equation. Negative x equals 2. If I go ahead and divide both sides by 1, positive divided by a negative is a negative. 2 divided by 1 is 2, so x equals negative 2. Okay, the next one. This is also an exponential equation. I can't make a common base though. I can't turn a 7 into something with a base of e. So what I have to do is cancel e. Remember, if you are trying to cancel e, what you need is a natural log. What you do to one side, you do to the other. So here to cancel e, so x is all by itself, I just take the natural log of each side. because natural log and e cancel one another. So x equals the natural log of 7. This is something that we'll have to go ahead and put in the calculator, so hopefully you have that handy. Remember, natural log can be found right underneath your common log button. Natural log of 7, and I'm going to go approximately because I am rounding, and if I go to 3 places, 1.946. Again, approximate versus an equals because I did round. Okay, the next one. If I'm trying to cancel a natural log, you need an e. So if I take both sides to a base of e and a natural log cancel. X equals e to the negative power of 3. Now again, I can put this in the calculator. E is right above natural log. So you hit second natural log. Notice that it automatically tells you that e is a base. E is to the power of something. For us, that something happens to be negative 3. Now if I go ahead and round it to 3 places, 0.04, oh boy, it's 98. So if I want to round, I would have to go 50. Okay, so again, and it didn't tell us how to round. So you could have gone ahead and rounded to 4 places, rounded to 2 places. For some reason today, I was just feeling like rounding to 3 places. Okay, so 1, 2, perfect. Okay, let's keep on going. Now this is a log. If I want to cancel a log, I need to take it to the base, an exponential base. The value has to match the base of the log. So what that looks like here, this is a log. It doesn't have a base written, so it's an unwritten base of 10. To cancel a log with a base of 10, you need to give it an exponential base of 10. What you do to one side, you always do to the other. 10 to the log base 10 cancels. X is alone. This is 10 to the negative first power, which is the same thing as 1 over 10 or 0.1. So to cancel a log, you need to take it to the exponential base of the same number that you find as the base of the log. Okay, the next one. If I look here, I need to simplify this, okay? Because I know this is an exponential equation. I want to see if I can get a common base. Well, you can't do that until you've simplified it as much as you can. So the first thing I need to do is divide this 3 to both sides. So 2x would be remaining. If I take 42 divided by 3, it's 14. So now if I look at this, can I take 14 and get 14 from a base of 2? Well, 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. So I went on either side of that 14 and it didn't work, okay? So let's look. It's an exponential equation. We cannot make common bases. So if not, you take the log of each side. So what I have to do is take the log of both sides. This would look like this. Log of 2 to the power of x equals the log of 14. Now what you need to remember is that you cannot have an exponent on a log. That exponent needs to come out front. So it's x times the log of 2 equals the log of 14. This is a product. When you bring your exponent out front, you are multiplying. So if I want to cancel the log of 2, so that way I can isolate x, I need to do the opposite operation. Since this is a product, I simply just have to divide both sides by the log of 2. So x, this you already did in 3.3. We did that change of base formula. So you enter this in the calculator the same way. Log of 14, close the parentheses, there's the top. Divided by log of 2. So if I divide it, this is approximately 3.807. Okay, let's keep going. I have quite a few examples. Number 1, because I think this is really fun. And number 2, every problem is a little bit different. So I think in order to really show you how this works, I need to have a lot of examples. Okay, let's keep going. Now, if I want to solve for x, ultimately I need to cancel the e, so I get rid of that base. Well, you can't cancel an e unless you isolate it. So step 1, I would go ahead and add 3 to each side. So I would have 4e to the 2x equals 2 plus 3 is 5. Even if I took the natural log right now of each side, the natural log would not cancel e because they have to be connected. So before I take the natural log of each side, I need to get rid of that 4. This was 4 times e to the power of 2x, so to undo multiplication, I need to divide. E to the power of 2x equals 5 divided by 4 is 1.25. Now that I have e out front, take the natural log of each side. Because ln and e cancel, 2x is what I have left. This I have to put in my calculator. So natural log of 1.25. I get 0.223. And again, notice that I switched it to an approximate answer. It's not exactly because I'm not writing every single value. Go ahead and divide both sides by 2. And x is approximately, if I take 0.223 and I divide it by 2, I get 0.112 if I'm rounding it to 3 places. Okay, let's do another one that is just like that. Okay, so step 1. I need to isolate my exponential base. So I'm going to first add 4 to each side. 2 times 3 to the 2t minus 5 equals 11 plus 4 is 15. To get rid of this 2, because right now this is a product, I need to divide both sides by 2. 3 to the 2t minus 5 equals 15 divided by 2 is 7.5. So now it's time to look and ask yourself, can I make a common base? I can. I can't turn 3 and 7.5 into a common base. If you cannot make a common base, you take the log of each side. Now there's that rule with logarithms. You cannot have an exponent. This time my exponent is more than one term, so when I bring it out front, I'm putting it in parentheses because I need to keep this exponent together at this point. So you would have 2t minus 5 in front of log of 3. That is a product. Equals the log of 7.5. Okay, so I could not make a common base. I took the log of each side. You cannot have an exponent on a log, so I had to bring it out front as a product. Now I need to divide the log of 3 to each side because now this is gone. So I'd have 2t minus 5 is approximately, let's put this in the calculator, log of 7.5 divided by log of 3. If I round it, it's approximately 1.834. Now I'm just solving a two-step equation. If I add 5 to each side, I would have 1.834 plus 5 is 6.834. Then divide both sides by 2. If I divide both sides by 2, t is approximately 3.417. Okay, the next one. Here's one of those really cool properties. If both sides have one logarithm, this is one log, this is one log, and they have the same base, like they do here. This is a log base 3, this is a log base 3. You can just cancel them. So here's my equation. 5x minus 1 equals x plus 7. Because there was one log on each side and they both had the same base, you have a property where you can totally just cross that off. In order to get x's all together on one side, if I minus 1x to each side, 5x minus x is 4x minus 1 equals 7. If I add 1, I would have 4x equals 8. Divide both sides by 4, and x equals 2. Okay, the next one, just to go back to those natural logs. If I want to cancel a natural log, you need to use an exponential base e, because e cancels a natural log. So this is 3x is approximately, this is e to the power of 2. So second ln, e to the power of what? We want it to the power of 2. So I have approximately 7.389. Now, all I need to do is just divide both sides by 3. So if I have 7.389 and I divide it by 3, x is approximately 2.463. Okay, here again, I see that there's a natural log, but I can't take it to the base of e yet because all this stuff is in the way, okay? You need to isolate it first. So if I go ahead and I minus 5 to each side, I would have 2 times the natural log of x equals positive 4 minus 5 is a negative 1. I cannot cancel a natural log with a number in front of it. This is a product, so I need to go ahead and divide to each side. So natural log of x equals negative 1/2. Now, to cancel a natural log, you take both sides to the base of e, because e and a natural log cancels. X is alone. If I take e to the negative 1/2, I'd have 0.607 if I rounded it to 3 places. 0.607. Okay, last one. If I want to cancel a log with a base of 5, I need to give it an exponential base of 5, but right now it's not going to work because there's a number in front. When you have a number in front, this is a product. So in order to undo that multiplication, I need to divide. Log base 5 of 3x equals 4 divided by 2 is 2. Now, to cancel a log with a base of 5, you need to give it an exponential base of 5. These two numbers have to match so I can cross that off. So 3x equals, now remember this is an exponential base, so this is 5 to the power of 2. 5 times 5 is 25. Go ahead and divide both sides by 3. If I take 25 divided by 3, I get 8 1/3 or 8.3 repeating. Okay, so there were 13 samples of how you can solve exponential and logarithmic equations. Okay, so your assignment today is to go ahead and work on a worksheet. These notes are going to be super helpful, so definitely keep them right next to you. But before we leave from our notes, let's go ahead and look at an application problem. You have deposited $500 in an account, and that account pays you 6.75% interest. It's compounded continuously. Remember, as soon as you see continuously, that's that PERT formula. The principal, the base E, to the interest rate as a decimal times T, the amount of years. Here's the question. How long will it take your money to double? Okay, so the principal, how much did you deposit? 500. E is a number. To the interest rate, 6.75% as a decimal is 0.0675. The question says, how long will it take? So we're trying to solve for T, time, how many years? For it to double. So double, if you put 500 in, if you're looking for it to double, you want to know when it's going to be worth 1,000. So here's your equation. Yes, I know I'm going to have to use a natural log to cancel an E, but not yet. I need to have this all by itself first, meaning I need to get rid of this 500. If I divide both sides by 500, e to the 0.0675t equals 1,000 divided by 5 is 2. Now, to cancel e, you need to take the natural log of each side. So this cancels. 0.0675t is approximately, let's take the natural log of 2. I have 0.693. Last step, to solve for t. Divide by 0.0675, 0.0675. So t is approximately, let's go ahead and divide it, 0.693 divided by 0.0675. T is approximately 10.267 years. So if you could put $500 in the bank and the bank said, hey, we are compounding continuously and the interest rate was 6.75%, if you could leave that money alone, don't touch it at all, and you went back a few months after 10 years and you said, hey, give me my money, your money would have doubled and they'd be giving you $1,000. Okay, so super cool stuff. Again, the assignment that you'll actually turn in for a grade is a worksheet. If you really like this or you feel like you need more practice, there are some really good questions in the book. You can find those questions on pages 221 to 223. And again, if you are ever working through the suggested problems and you have questions, please let me know. Send me a message. We could even do a one-on-one Zoom if you'd like. I hope you guys are having a great day, and I hope you enjoyed solving logarithmic and exponential equations. Peace out.